Hello and welcome back to Algo World. When last we met, we were creating this class object that generated a graph data structure for us. We added nodes, we found things in the graph, we deleted nodes, we saw if things were adjacent, and we printed it out. And well, last time I said we're going to add a method to traverse this graph. And well, let's get started with that. First thing I'm going to do is actually change up this class a little bit. I want to know where this is going to be starting, so I'm going to create a constructor argument called the start node. I'm not too interested in the size anymore, although I think in the last video I made a typo and left it as like sizier or something to that effect. All right, now I've created a variable called current, and that's where we're going to place our start node for now. And this time I'm going to define an object in my constructor to hold all of my methods, because I honestly think that looks a little cleaner. And I've always kind of liked doing, like, in this case, g1.operations. Whatever I need to do. Anyway, instead of add node, we're going to change this one to set, and it's still going to require a key and our spread operator for our values. All right, so this time, this time we're going to take our graph object and do well, basically the same exact thing that we did last time. We're going to set the key to some new set which contains all of our values. All right. And we'll name this next method get. Get is going to get our key, and this one is going to return the value that we're looking for in our graph. All right, the next one is delete, because I'm fairly certain that if you're going to use this for game development, which, I mean, I would, that you're probably going to want to be able to refresh this thing every now and then as you enter different areas, like changing from your overworld into your building 1 or building 2. Anyway, so we're going to call the delete operation and pass in our key. And the last thing that we're going to add into our operations is our adjacency function. We want to know from and to. And we're going to return .graph.get. We're going to get from and see if that has to. So it's seeing if the node that you're trying to get from has the node that you're trying to get to in list of nodes that it itself is adjacent to. If you're like me, you probably like to keep up with some of the specifications about your graph, so we'll just drop this in here real quickly. The number of nodes will always be equal to the size of your graph, and that is already built in to the mapped objects. Now, edges is it's a little different. We'll define a variable called value. We'll initialize it at 0. And then we'll do this dot graph for each. We're going to do a for each loop. We'll call this value entry. And on the inside, we're going to set our value plus equal to entry dot size. So what it's doing is it's looping through all of the keys and counting how many nodes are incident to that node. And what we're going to do is return the value divided by 2. And that'll be the exact number of edges that you have in your graph. Now, our very last method that we're going to add in here, we're just going to call this traverse. And the argument you're going to pass in is the node that you're trying to traverse to. And this one's really simple. If it has that node that you're trying to get to, then we'll go ahead and change the current to the node 2. Actually, I think that's it. We don't have to return anything. So here's our code as it currently stands. We can set, get, delete, find the adjacency. We can determine the number of nodes and the number of edges, and we can traverse our graph. We don't need to delete G1. All right. But we do need to set some values. So I mocked up a little graph for us to follow while we're setting this one up. So this first one will be node A. Node A will contain node B, so it can go from A to B. B can go from B to A. B can also go to C, and C can go to A. But A can never go directly to C. It has to traverse through B first. I believe that's it. A goes to B, B can go back to A, B can go to C, and C can go to A. Yep, that should do it. So what we're going to do is print out the current the current node, and then we're going to I think this is how I did it. Then we're going to try to traverse. I don't need that. Nah. It's been a long day. Anyway, no, I don't need operations. I just need to traverse. We're trying to get from our current. No. We just have to put the one we're trying to get to. Trying to get to B. Then we'll put U1 dot current. All right, so if I've done this correct, this should work. And sure enough, it did. We went from our node A to our node B. So if we go and traverse to node C, it should show that we've gotten to node C. And if we try to go back to node B, it should remain at node C. All right, cross your fingers. Well, what do you know? Got it right the first time. Now I'm suspicious of this code. Just kidding. Well, I hope you've learned something from this video, and I hope you'll like and subscribe, and I'll see you again in the future. Have a nice day.